required to also go with extra data from another data table, perhaps might not deliver you, consistent records. Okay, and so that's another possibility as to why our data may be inconsistent. Okay, and so lastly is what I was saying previously, the duplicate records that come in from various data sources. In one data source, you have a record of Mugonza Peter, and or something like where we have often seen in the second data source and have something Mu or Peter. Those might be actually similar data records. Okay, although now they are being presented by different data sources as if they are different. So now a little digging deeper into the other details about this same entity within those two records may actually spill the fact that surely, even if a few characters were missing, but indeed this is the same one data record. Okay, we've seen why data is data. That is surely it's data simply because of input incompleteness. Data is data simply because it has incorrect values that are coming in from various data sources, are coming in from errors due to transmission, human and or computer error, or factor, fault data collection instruments, inconsistency, and duplicacy. Okay, and so as our role is to see to it that we can correct such kind of outliers, smoothen data, fix all such issues, such that before our data is pushed over into a one clear data store that we are calling, say, for example, a warehouse, is surely clean and of good quality. So now, surely no quality data that you present and expect efficient or good mining results. Okay, so now similar statement, garbage in, garbage out. Okay, and so quality decisions will be essentially be based on good quality data. And so take it in mind that surely as a data miner, things like duplicate data, missing data, often those are what you often want to look at. But surely we have to eliminate quite as much as possible. Observe quite a lot of other things that we have looked at in the previous slide. Okay, so you need quite a lot of consistency, even as you integrate data from one data source, from quite several data sources. Okay, and so there's one thing that I think if you're not into data and may perhaps a role of a data entrant, a data analyst, a data manager, it might become very hard for you to tell of the challenge that poor quality data presents to the desire for efficient results or analysis results. Okay, and so until when you get involved in that is when you should surely sense that, when I have data, my data has to be of good quality for me to ensure that even my analyses or my results or my everything that is going to come from the data, my interpretation is going to be of good, judgment and will be of sense. Okay, and so that becomes one of the largest problems to any data mining task or process. Okay, the issue of data pre-processing. We need data to be pre-processed such that at least we can rely on such data. The idea is, can I trust this data before me? Okay, and so if it's not of good quality, there's no way you are going to trust that data for very good decisions. Okay, and so you need to perform things like data extraction. You need to clean the data. You need to transform the data just in case it is low scaled, and then you usually apply scaling and then have the data run under one single scale, and then eliminate the outliers as much as possible. And surely all these tasks, I hope that as you conclude today's engagement, you will, which I do believe ends with our, exposure to what we call a data warehouse and data warehouse design. All these kind of terms, extraction, cleaning, transformation, should not be a problem or should not be new to you anymore. And surely, what do we mean by high quality data? Okay, quality data is surely multidimensional. And so in the case of understanding high quality data needs to be accurate. Surely, data needs to be accurate. When you get to know that surely the data enumerators that we are going to use, okay, are not those that you can trust. Better not to take on the data collection task and wait until when you have trustable persons, okay? Otherwise, the kind of heck that you will surely experience will be too much. You need to have people you can trust such that they can collect for you accurate data. Better create means for, accuracy checking, okay? Create such means at least points at any very time when you have to double check for accuracy, when you have to double check for completeness, you need to double check for consistency. And so that's why you often hear that such jobs are very high paying. And so when a job is high paying, you as a data enumerator, you as a data manager, you then have to caution your enumerators that, oh, please, this is country data. We need to, attend to it, in a much better, vibe. So now you need the best for the best. So now data needs to be timely. And so now if data is not timely, say for example, if it is, we require data that is 2 years old, surely that data should be 2 years. Okay, and so now it's not going to be a 10-year-old data, and you want to base all your efforts to, to get insights for your decision making. Generally, we shall have gone into now research. Okay, perhaps there's some, interestingness that you may be, attracted to about data. Say, for example, you've spent quite a lot of time minus running any data mining, and so you want to really practice. Okay, but data needs to be timely. So now, remember, you need to trust data. Okay, and so if you cannot trust that data to give you the appropriate insights, then surely better we recollect such data. Or you can ignore some of the data sources simply because you realize that, oh no, this data cannot be what? Trusted, okay? And indeed, when you have trust for such data, then you are sure deepest into your small mind that surely at least I know when I undertake my data mining, machine learning, AI tasks, I know there is something of interest, okay? There is value that is surely added to your data by you simply looking at it. We simply say that if I can't trust that data, surely it's most probably that interpreting it will be very, very hectic. And so I have a data row or I have a data set and it does not have metadata. Okay, it does not have any descriptive data for such kind of data set. It is also poor quality data. We need to have a means to interpret that data. If the means is not there, then get to know it is going to be, research. Okay, that's not the case. We often, run such kind of data mining tasks to have something of interest. And so if the interestingness is not there, then surely we are just simply going to push it into research to discover anything. Okay. So now also we need to be able to access data. So data, high quality data has such measures that enable us to tell that this indeed is good data. So if data is not accessible, then surely it becomes very bad quality. So now if you cannot access it, then why not? Why then take on any efforts then? Okay. So better the other broader categories of the multidimensionality of data quality is that data should surely present something intrinsic about, say, for example, the entities of interest. As it has to be contextual. Is it periodical? Is it for a certain is it specific about certain community? Is it specific about a certain disease? It needs to be representational. Okay, and so am I speaking about say for example a disease A B C D and so if this is the disease, then surely does it present the particular, say, characterization that, say, for example, when I observe from these particular fields, then surely I should either get those that have the disease and all the rest will not be having a disease. Surely it needs to be representational. Needs to be representational. If we captured data about this disease, then the fields surely are those ones that I expected. So now, surely, if I'm not able to, simply by look at the data values, not to be and fail to present the understanding of a certain thing entity, then surely that data is not representational. It's not interpretable. And so, what we saw previously in the eight measures for data quality, accessibility still stands. Okay, so broadly, those particular four ones also can be utilized to describe the multi-dimensional view of data quality. And so major tasks in data preprocessing that surely we keep talking about data cleaning. Why we say data cleaning is because surely data is data, okay? And so we have to fill in the missing values. We have to clear the noise by smoothing our data and then remove as much outliers as possible, much of the errors as possible. We are pushed to identify and remove as much inconsistencies as we can. So as we do so, we are surely ensuring that our data is going to be of high quality. Okay. And so in addition to data cleaning, this is the same talk. Surely we do integrate data. Apart from data integration, we do transform data. Data transformation, when we have poorly scaled data from one data source and so the other data source has well-scaled data, then we might be pushed to transform our data such that it is same kind of scaling, and then if it requires aggregating, then also two possible. We can also do what? Aggregate our data such that at least now we can speak at an aggregated level. Okay. Although we shall later on see how aggregation may be also may limit some level of good decision making or good insights development. Okay, and so in addition to data transformation, you should realize that from all our talk today, we are saying that all the 9.4 petabytes of data are not going to be utilized in your data mining task. But just simply because there is that representationality, okay, of your data. It is possible that we can simply take a portion of it and then can run you know the analytics that can provide similar what results. And in addition to that is surely a subfield of data reduction that we call data discretization, okay, that still similarly can provide us importance with a little scaled data, okay. Graphically, we can illustrate data cleaning. Say, for example, you have data with quite a lot of stones. Now, by simply doing a little winnowing, we are able to later on be left with very shiny, smart, clean, bright data. Okay, and so we were simply indicating that also for data integration, we indicate that different data sources. One could be, say for example, a database. The other may be a simply, say for example, already a set of data from your main, databases. And all one could be simply a flat file. Okay, and so all these can be integrated into a one huge store. Okay, simply because they have a little similar data, data about some entities of interest, which we need to focus on, and so can be integrated. Lastly, but not least, is the transformation from one scaling to another scaling, such that now the analytic results can be of sense. We have seen the reduction. So by mere reducing of the size of our data, all by simply picking any amount of the data from the huge data set, okay, can still guarantee us an opportunity of getting the actual similar results as though you utilize as if you utilize the other huge 9.5 petabytes collected of, say, for example, cancer genomics, or some of the data sets from archives, huge archives. Okay, so now by simply picking a little of that, that too can still aid in getting very good results. Okay. And so now, when we pre-process our data, we've seen why we process our data. So now, some of the tasks now can take place. We can then undertake some of those tasks. Let's see how most of these tasks, look like. What you undergo surely will be something similar to this, okay? And so just after our next slides, or lecture notes on data warehousing, surely we should be able to, exercise whatever we have looked at today, and, get the best feel practically of how you undergo data preprocessing. Most of those activities that we are seeing today should be possible also on your side. So now, next is descriptive data summarization. Why do we do descriptive data summarization? Descriptive data summarization is done simply to get a better understanding of the data that is presented to us. Okay, essentially things that of interest that we want to always see about data is what unique entities can basically, by seeing, can represent our data. Not entities, I think, but what unique characteristics can surely represent this data that is before me. I could then say, oh, the mean value of their mean age, okay, of all those participants were this, of the study participants were this. I may want to look into several measures of central tendency, and so central tendency is one of those things that are of interest. And at times, if you do not do so, you would also want to see, oh, how most of my data about, say, these patients dispersed. How does it vary? Okay, how is this data varying? Surely, how is it spread? Okay, now things like variation and spread would be of interest. If we look at you as a first-time data scholar and you are presented data, you should the first things simply dive into understanding the data. If you cannot understand that data, then surely it is of no use. Okay, so now data we saw by looking at descriptive characteristics, we can then look into things we call median. We are able to look at what is the maximum value, what is the minimum value, okay, and then you know some analysts may be interested in seeing some quartiles. Of course, all of you I hope that as I introduce this material to you, you too on your side are busy thinking about much of these tasks that Robert is presenting to us. Surely, how applicable are they back down into my job field? Okay, into my roles as you know, in whatever capacity you're in at the organization you're working in. Okay, and in so doing, you busy thinking of, I think after here, I need to see how these can be part of my day-to-day tasks. Okay, and if, say for example, this whatever we're talking about is stuff that you undergo on a day-to-day basis as a data manager, as an analyst in the organization. And I know some this might also be new, but then get hooked into that area, because I want your thinking, I want everything that you usually do be you know somehow linked to what we are talking about today. Okay, that's the kind of minor I want to see in today's class. Okay, and so when we have seen that the idea of you know mining data descriptive characteristics would aid. Okay, it would surely aid in understanding our data. So as you as a first timer, or you surely used to data and it's not your first time, let us get to realize how these can be of interest. And so in addition to dispersion characteristics, we look at some numerical dimensions, okay, that at times that may be applied to sorted intervals, okay, intervals of age, intervals of certain fields, okay, of things like data dispersion. Might you now coining quite a lot, yeah. But then we also use things that we call box plot, or what we talked about as quartiles. So now the box plot analysis will then include the use of maximum, minimum quartiles, okay, in order to understand exactly certain data that is before us, okay? And so when we have that this unique initial understanding, then we can proceed on and see whether the rest are not an issue. When we are concluding that, then it is okay for you to now present that data now for updating into what we call a data warehouse. Okay. Yes. Generally, we utilize such kind of characteristics in trying to understand our data for the first time. We first time analyze, and when you look at any data, those are the first things that you would want to actually put to focus or to utilize. And then the other is simply a central tendency. So when you speak about central tendency, we simply mean some of those measures that describe data that is together, and generally the much more intrinsic characteristic about such data would be your measure of central tendency. Things like mean, things like median, things like mode. And on the sides, not to waste much more time, we include some of those formulas to those that have already forgotten. Okay, we do calculate mean, how we do calculate median, and when we have mean and mode, we can have median. And or when we two, we can have the kind of measure. And so further as we try to understand the data that is before us, we focus Okay, that's how the Uganda we live in is modeled, even with such basic facilities and services. So, surely, pardon the network, pardon where I am. Otherwise, the connection should have been very, very, efficient. Okay, and then we would have a very good engagement. Okay, so I was simply talking about skewness and how surely our our good our good and normally distributed data can present different states. Okay, now
Doctor,
if yes, please.
excuse me, Doctor. I
Please.
think your network got off when you're on the previous slide. So we don't know how it comes to the symmetric and skewed data now.
Okay, so
Yeah, we're still trying to understand this point.
At that particular one, eh?
Yeah,
Okay,
yeah.
so surely at this particular slide, we were saying that surely some of the intrinsic characteristics of a data set include how centrally our data is positioned. Okay, and so some of the those measures that allow us to have such data positioning include things like mean. And so when we talk about mean, we also can infer a sample mean or population mean, all are algebraic kind of mean. Okay. At times, if non-sample mean or population mean, our mean can also be attached some weights. So, and then such mean might be referred to as weighted mean. Okay. Or our mean could be also trimmed. Okay. So now by trimming mean, we would be simply, chopping some extreme values of our mean. By all the sense, in all, we would be aiming onto getting at least that central measure that can surely represent our data. So now, that enable us to achieve sample. Some of those formulas are over onto the right. Okay, so if you have forgotten, then it should become still easier for you to exercise and recall how most of those means can be calculated. Now is not the time that we would venture into that, but then getting to know of and be reminded of such things. So now the median, of course, that means our middle value of a certain kind of field values. Okay, and so holistically, median would be the best measure of central tendency. Okay, but then we really see that you cannot describe data just with median alone. You'd want to have a closer view of these three things: how the data is the mean of the data, the median of the data, and the mode. So now, how we calculate most of these things is and some data could have a one single mode, and so now we can call it unimodal. Say, for example, we could have also two modes, okay, and in so doing, and so we would end up calling such data by model, okay, or it could be more than two, and then could be a trimodal. Okay, and so now when we have two of those measures, it's possible to get the third measure. Okay, and so now when we have such data set of when we have such central tendency measures, then that formula at the bottom, that empirical formula, should basically enable us to get to the third measure. So mean, mode, you can get what? Median, and so forth. And so all those formulas are still presented here such that we can be able to recall these things that we we were able to meet some long time ago, but now they're getting back into the picture. And in addition to central tendency, you would want to observe how our data is positioned, against the normal, normal lines, our mean, how our data is dispersed, how our data is spread, okay? And so in a data set, you'd want to see, or in a data value, you may want to see how that data is surely spread, away from the mean, median, and say, for example, average, okay? And so it introduces to us what we call skewness, okay, or symmetricity of data, okay? And so our data can be either negatively skewed or positively skewed. And if not those particular two ones, then it is surely normally distributed, and what we can surely see are those various illustrations of a normal distribution, surely on the bottom, okay, bottom left, right, bottom right, okay, and then we can surely see how our data is negatively distributed, on our left, bottom left, and positively distributed on what we call in the topmost left, right, or topmost right, okay? And so now the meaning is that we are trying to understand our data. And so now if we do not have such things, then it becomes very hard to surely understand a data set that is presented before you. And so when we have such a skewness in the data set, we can then be able to say we get some data. If we do not perform some aggregation, then we can rescale the data. And so by doing such rescaling or what we call smoothing, okay, it becomes hard for you to make very good interpretation of such kind of data. And so in addition to central tendency, what we saw previously was dispersion or spread, okay? And so measures like quartiles, box plots, and not box plots, but then measures like the calculated one that we call the interquartile range, okay? The others that we call minimum, maximum, okay? All those surely continue to inform us of how our data is spread, okay? And so often when we have such measures into use for observing dispersion, box plots are then desired kind of graphs, desired facilities that we put to use in describing how our data is surely dispersed. So now when you want to plot, then the use of box plots would do a very great job, okay? In addition to when we want to, say, for example, group our data, now box plots will surely help us to achieve so. By observing a single box plot, informs you quite a lot of characteristics about such a field and its data values. Yes, we are seeing that in addition to all those is what we call variance and standard deviation. Before actually you walk into quartiles and usage of the box plots, okay, the first things that come into the data miner's mind is can I see how this data is spread away from the mean, okay? And so variancy is and standard deviation are those two core measures that help us to get this particular field about the data that we have. So now you can have the population variancy, sample variancy, algebraic variancy, and then you can have the deviations, standard deviations for the sample and population. Okay, and just simply pausing at this particular one, by simply knowing how data is spread, okay, also is a very good requirement for understanding certain performances of certain algorithms that we use in data mining tasks. Okay. The squared mean root error, things like those. So now when you meet this at this particular time, take it in mind that later on we are going to meet them. We are not only looking at them here, but then also elsewhere as we apply our data mining tasks onto the data. Okay, we shall still meet some of these things, and they should be of some meaning when we meet them. Okay, say for example, when we do classify, okay, certain error types will surely mean quite a lot, and so now error types that relate to squared mean root error, are calculated almost using similar formulas, and so in your calculation you should not find this very, very difficult to interpret. Okay. Yes. Normal distribution and skewness surely can still be revisited. We talked about box plot analysis, and we have seen that surely a closer view of box plot analysis can also help us understand, a certain field plus its values. Okay. Okay, so then from data summarization, I did not want to over delay into it simply because most of these measures have been encountered in our lives as either computer scientists, a sociologist, one doing medicine, all sorts of programs. I see have at some point when we revisit such kind of thing, simple basic statistics, and there's no way we can progress in life when we do not in our life as a postgraduate, minus thinking about these things for use in your project for your program, the final year program project. So you need to understand these things very well and put to use such that the vocabulary can then be enriched come the defense of such kind of results from your analysis. And so I will not waste so much also time on data cleaning, but I would wish that data cleaning is done entirely. So we observe data cleaning as one of the three biggest problems in data mining. However, though Kimball identifies it as one of the core problems of data warehousing. Okay. Yes, data cleaning, we've said that surely is a very, very big problem. And it takes surely a very broader mind, a multi-viewed mind of the data that is before you, and such that you can have very good, high-quality data. So data cleaning is one of those problems in data warehousing. You see that both references identify it as one of the hardest problems, hardest challenges in data mining. And so now observing that as a task at data warehousing, data cleaning presents that as a state or as an issue to data warehousing as an entire step or phase. Yes, some of the tasks that we encounter in data cleaning include filling in where we have missing values, identifying outliers, and aim at making sure now those particular errors are corrected, okay? Making sure that now noise is reduced. Now, apart from simply reducing, but we can entirely eliminate what? The noise, okay? And so apart from eliminating noise, your aim would be into also making sure our data is consistent. And so otherwise, if it's not consistent, I told you that initially that we can ignore that data set and then can go out for a data set that is at least a little much more consistent. Otherwise, the results might be affected. We would want to eliminate as much duplicacy as possible, such that at least redundancy is not one of those things now are going to come up from your particular data or that you are archiving. Okay. This is simply possible simply because you have different data sources and duplicate data can appear. And so when we transfer all that into our warehouse, okay, it will create redundancy. Okay, now let's see with missing data, where we have missing data, how then can we correct this? Surely, how we can correct this and is surely when we do infer. Okay, so most of you remember very well the regression line. Okay, so when I have all the other data tuples, or when I have the fields and their values, okay, plotted on perhaps one single rule and try to be fit on that rule, I'll be able to interpolate and then infer or predict a value perhaps that was missing. All the other avenues would be you trying to fill it in manually. Okay, you may want to see how to, and now you observe the other fields, the other records, the other tuples very well, and see exactly now if this other tuple has this. I do believe that this one with missing should have looked like this. Okay, and so when we fill that in, say manually, we realize that that could be very tedious. Just in case you have a billion records, a billion tuples. Okay, now that will be a little very difficult. Okay, however, now with automated tools, okay, now we can surely simply set certain figures that can help correct such challenges, okay, or such kind of missing field kind of issues, okay. The case in kind when we can use a global constant, and then safe example can say that everywhere we have missing values, okay. I do realize that a missing value can now be called, can be then coded with a new number, okay. We could either give it what we call, say for example, when you look at that entire attribute, you could say that I know the most commonest of the values of this particular attribute is this, okay. And so we take it that this is not an outlier, but then because it's also data within the same data set where we are collected, then we can say let us simply replace the empty space with what that particular what attribute value. Say the mean, or we can say if it's not the mean, then we could say the mode, okay? But then by using mode, it's like you introducing now another mode into the data set. Now, better when you can use the median and mean, okay? That would surely smarten your correction of missing values. And I don't know in the team, do we have any data managers? Patrick, Joshua, Peace, Anthony, do we have any data managers surely within the team? Baluku, who amongst us are very good data managers? I want us to live, I want us to feel exactly what we're looking at today, that is surely is part of our blood. Do we have any data managers or team? Who amongst us is a data manager? You work with some data sometimes, so team, okay? And then how do you correct missing values, missing fields? You do provide now a new code. Mm-hmm. Could be discrete in the case, okay. Okay. So for example, mm, mm, yes. Okay. Oh, so you're going to enjoy your activity that is after here. Yes, with the rest, apart from Otem, who else surely is engaged in uh, data management in their organization? Say, for example, in research, on a day-to-day basis, as say, for example, a systems admin, a data, a research assistant, okay? Who amongst us surely, apart from a team, does these things on a day-to-day basis? Peace. What do we do? What do we do at our organization? What is our job role?
System management.
System management. Usually, good system management. Okay, system management. Do we ever encounter any missing data?
Yes.
And how do you correct system, missing data?
It depends. If
It depends.
sometimes they send it back to the field to be corrected. If it is not going to, if its impact is minimal.
Okay.
Yeah.
Mm. Okay. Beat around the bush. You tell us what how we not trace data owner. Okay. Yes, we were still with you, Peace, and sorry, these still have to happen. Okay. Yes, you're still telling us about, you know how you handle some of that. That is not going to go back in the field, and you could handle it within before the analysts themselves, or before the automated analytics platform that you have put in place.
Replace it with constant values.
Say, for example, like a NaN, like a 999.
Such that whoever is interacting with the data, when they come upon that one, they know.
They know. Okay. Okay, so now, else, I know some of us, I think, might find it a little hard telling us that surely you also encounter data, but then apart from that is that we could always use the most probable value. So we simply infer using either a regression line or a Bayesian formula or a decision tree. Okay. So now when we do run a model of interest onto such similar data, we can already get some certain rules that we can use to infer. We can infer, say, for example, because in a certain tuple, A, B, C, D, but then F also at some point, has that particular value. It's also possible that amongst the very many, that this similar value can also be be applied to, say, a tuple whose missing value for such a certain for a certain field of interest is where we have a missing value. So we can use such an inferred kind of value. Okay. Yes. I know the decision tree, Bayesian formula are some new things now to you, but then end of our activity, some of these things should start appearing in our vocabulary in our lives as data miners. Okay. Yes. What of noisy data? How have you handled it? Say you want to go back to a team. Yes, Stella, this time has a point. Let's first listen it because we now need to share experiences apart from the material itself being before us, and then I know you are also going to share. Yes, Emmanuel. Yes, how do you then handle noisy data where we have errors? Okay, how have you been handling that one? Okay. Hmm. Okay. Okay, I think that's still entry errors. Mm. Yes, yes, yes. Yes, you have a means of tracing, eh? Mm. 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 15. Mm. Mm. And say for example, when you have participants for whom you know very well that this data set is on say patients within the age bracket of say for example 13 years to 18 or 23 years, okay, and then within the data set you have for that particular attribute or for that particular field, you realize that you now have an age range of 45. Surely, somewhere, somehow, something happened. Okay, and so now it is then taken upon the data manager or at times organizations actually emphasize that you, the research assistant or data collector, the enumerator, you do not submit data before observing that such noise is eliminated. Okay, so you have that sole task of making sure such things are corrected before you submitting that data. But then where you have such organizations, then get to know the enumerators are going to play around with the data such that it does what you the management require to be done. And so at some point, if the quality assurance, personal monitoring and evaluation, I would then feel like, I think this data, I don't need to trust it if at all this is the approach, so better let the data come in the way it is, and then you can apply what Emma and Peace were suggesting. Okay, you realize it at the managerial level, and then can task whoever collected data from a certain region on a certain group of participants to actually go back and fix that. Okay. However, now when we have data stored in, say, for example, archives like those, also at archiving institutions that take on the role of archiving, play a bigger role of not availing data that is problematic like that. Okay, and so when you encounter it in that manner, then what you ought doing is ignoring that particular tuple. So we may reduce it from the entire data set of interest. Okay. Yeah. Sorry. And so such things, and in addition, where we realize that, say in the capturing, some participants or some entity data is surely low records as compared to the others, and so you realize quite a lot of noise in the data. Quite a lot of outliers, then it is possible that we can surely now attempt quite a number of other techniques. Now, one of the techniques is binning. Okay. Now, the techniques of binning help quite a lot in the sense that even whatever we are going to infer or suggest as a correction of an outlier, is surely related to the data that we are trying to fix. Okay, it is not external in the sense it's not very far away, it's not very spread from the actual data before us. Okay, and so we take on examples of binning as a technique. Okay, binning as a technique enables the data miner or the data cleaner to see how all this data can can be sorted fast. Once it is sorted, it is divided into equal number of beans or equal frequency beans. Okay, and all when we do so, then we pushed to correcting any noise with say the mean of the beans or the extremes of the beans, the bean boundaries, or say for example, we could use the median of the bean. Now the bean are simply groups, so we do group of equal frequencies. Say for example, if our total data set for not data set, if our total our total number of tuples that we ought to focus or evaluate is 20, then you may want to think about first organizing it, sorting it. I think we could sort it from the smallest to the largest, or you may want to sort from the largest to the smallest, and then once the sorting is done, then you can divide it into equal numbers. So you can either choose to have 2 beans or 4 beans, okay? And so when we have our beans, then we can always make the decision either for us to smoothen all that data by bean means, or smoothen the data by using the bean median. Of course, these are measures that you calculate, okay? You calculate and put to use. And we can either also use, if not those particular 2 ones, we can use the bean boundaries, okay? And so we can simply round off always towards the bean boundary. Is it towards the bean boundary or not? Okay. So now which particular bean boundary? The beginning bean boundary or the last bean boundary? Okay. And so we can go on smoothing it using the binning as a technique. Okay. We are later going to see how the binning works in the next slide. Okay. However, now if we are not doing binning, then we do estimate these. We can, infer using a regression line. Say, for example, fitting the data on in an XY plane, and then and then can simply infer a missing value, can infer can see how exactly a value that does not that not fit on that particular plane, and seeing it very far away from our line of best fit, okay, and then can correct it based on what we have already seen, the regression functions. So when we apply the regression function of that particular data, it should be able to be fed with the X, and then we can always have what? The Y. If we do not use the regression, then we simply group our tuples, okay? So when we group our tuples, randomly group these tuples in a number of groups. You can then decide to first say, let me make 3 groups, because with the with just a single perusing through this data, I realize that we may have it grouped into 3. It may also be grouped into 4 or 5 or 2, okay? Depending on what you have detected, okay? And so by simply clustering, you can detect that surely this particular tuple is supposed to be in this group, but you see, it is somehow very deviating away from what we do believe would have been the actual group where it belongs, and now we can see that it is much more closer to the other group than this other group. Okay, and so we can detect and remove such points from being in the other group. Okay, and so we can simply correct that either using also replacing the value that is creating that kind of deviation away by using either our attribute mean or the attribute median. Okay, in so doing, it corrects the noise and eliminates it totally. And then you realize that all that you would be doing for clustering, okay, and trying to understand your data would be
kufanya bidii. Kulisha taifa ni jambo la muhimu sana, ni jambo ambalo Kenya inahitaji.
Families have had to cut back, have had to make some tough decisions about getting rid of things that they don't need in order to make the investments that they do. We thought that it was entirely appropriate for our governments and our agencies to try to root out waste, large and small, in a systematic way. Obviously, this is even more important given the deficits that we've inherited and that have grown as a consequence of this recession. This makes these efforts even more imperative. Now, this does mean making some tough choices. It means cutting some programs that I think are worthy, but we may not be able to afford right now. We don't need to wait for Congress in order to do something about wasteful spending that's out there. Cutting waste, making government more efficient is something that leaders
I want to inquire from you because generally I've been using my institutional internet, network device, but today I decided to use my my telephone, my huge phone. So I'm using the same phone for my network. How has it been like this? Although we have been complaining that this one is not online, this one it goes on and off. Has it also been like this? Patrick, I know previously it was you. Now that you are saying that I am encountering the same challenge, you may want to also believe that I think it is the same thing that is going on.
I think, Doctor, the difference is this time round when it stabilizes, it becomes more audible than before.
It becomes more audible. Okay.
When it stabilizes, but at times it's just on and off. But then
So
for example, now you are clearly audible. Yeah.
But now at least it's more audible, right?
Yes, yes.
Okay, I thank you. And Stella, surely I can never, ignore your hand. You raised that hand. I almost felt like now this lady is going to take it that I did not consider her. Please, Stella, I want to hear your voice, Stella and Anthony. Okay, I want to hear your voices so soon. Okay, I want to hear your voices soon. Stella, is our arm still up, or we canceled it because of what I have said?
Thank you, Doctor. I think it was cancelled because I had just an inquiry.
Which piece corrected,
in
or
regards
which?
to data cleaning, I guess.
Okay.
Because I was trying to inquire during data cleaning as well, really. You're getting back maybe the people who collected data and so on, and you want. But then when you look at maybe the remaining data that is required maybe for cleaning is minimal, and the end results, and you see that including them won't even kind of make sense in that data. So is it delete those records or that data?
To me, just like how we said, because generally we could have a billion records, by simply ignoring a single data tuple, will not do much to your analytic results. You get it, eh? By simply ignoring it, it might not. Surely deleting might do, but then, but at some point, you realize that it may not affect the results from the analysis. Okay, might not affect the results from the analysis, and so it that might actually push the person conducting the analysis to adjust somehow. Because remember, when we speak of our sampling size, our sample size to be surface sample 200, we want to also be consistent that elsewhere in the analysis, surely I should have 200 tuples being utilized. You get it, eh? And so at some point you have to go back to the field and ensure that at least whatever was missing, whatever was noise or falsely provided is sorted. Okay. Yes, but then at some point, Anthony, I get a feeling that at some point, confidentiality is rendered absolute, because now if we are going to go back, remember, while picking data from these respondents, one thing that we keep doing is we inform them that, oh, please, we are not going to capture any important details about you. We want to make sure all this remains confidential, blah, 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 A, B, C, D. And so now look here, look at Anthony or Robert or any of you going back to, to trace this particular a participant of this study. It could be a breast cancer study. It could be any study, and so perhaps that participant's age perhaps was instead of being between 20 to 30 years of age, now you find that age is 45 years. Okay, and then you push to saying, no, we need to correct this noise, and so you are pushed to go back into the field. We realize that the confidentiality is going to be absolute. You get it? So how do you go back and convince this particular respondent? How do you handle it? How do you handle it surely? How do you still pull back these participants' trust? Anthony, how do you further build this back, the trust that they gave you, knowing that at least this is very, very serious data that you shouldn't just simply publicize. And so now these people are sure that by the time you manage to trace them back, perhaps that data is not confidential, something like that. And so now we have to fight a balance, okay, of confidentiality to be surely not absolute, but then making sure at least we can correct whatever we've had as an outlier. Okay, and even when we have missing data, the same can still be applied. Okay, I think just I am seeing a message from the course leader that I've delayed with you. I am going to work this fast such that I think I can create time for a very smaller task and then can come in later for your data warehousing engagement. Yes, and so and so when we observe binning, something that we saw previously, now we can see it in real action. Okay, so binning can still be handled in I think double sense. One is when we have eco-widgets. Okay, eco-widgets binning. Say for example, called the distance partitioning. Okay. The other is what we call the eco depth. Now, that is where it somehow it does confuse you a little bit. But I will simply make sure that these things are not confusing to you. And so the example I'm going to give you in the task will handle one specific type of binning, and then once we are done with that, my next example before your data warehousing, your engagement before we start, now we'll bring out those two types of what binning. One is the distance binning, and the other is what frequency binning. The idea, we have seen the approach of binning and how it is surely done. Okay, and so the practical implementation itself is one that I am interested in helping you bring out this particular kind of technique. Okay. Yes, what we use binning for, as you have been hearing, is removing the noise. Okay, removing the noise, removing the outliers. Now, in data mining, we regard to that as data smoothing. Okay, or data smoothing. Okay, whichever you would want to call it, but then we smoothen the data such that at least it is very clean and quality data. Okay, so I'm going to send this back to you. Okay, such that you can surely see the equal depth approach with simply patient edges of that type. Okay. Later, so now with the regression, we have spoken about plotting this on an XY plane. Okay, with the XY plane, we finally devise a function. Okay, a function is one that we are seeing say before us. So you would quickly see that the kind of function that is being utilized to have all this positioning of the data tuples is one that is a linear one. Okay, at times the regression might be nonlinear. And so you have to find a way that of how we use that function to infer. Okay, and so now when surely you can see that a point that had gotten misplaced so much this side, okay, can be corrected to the line, okay, where it missed the line, and we would assume that that is the immediate what that was the correct positioning of that particular tuple. So you can tell if I have X. If I have X, then I can have my new Y because of that particular function. So now, elsewhere, we do not use, say, for example, the other kind of kernel methods apart from regression. Now, regression enables us to simply interpolate and predict a value that we think perhaps might not have picked correctly. The other is cluster analysis. You remember I talked about clusters, groups, okay? So now if values are positioned in groups like this, okay, you can always tell, say, for example, certain tapo points. Now, like that one in the top most right, okay? You can quickly tell that, oh, this one was supposed to be into the group that is very closer to it, okay, than to a group that is very far away to it, okay? And so in so doing, we can then reposition and use what we call, even if it is going to just simply stand within, but then what we call the cluster middle cluster point, okay, that we are calling the centroid, okay, can still be utilized in smoothing, okay, data about this particular tuple, okay, and so forth, and so on and so forth. I don't know if that was very clear. So because of this, the most left right, the most right bottom right point, you can see it. The most bottom right point, okay. Oh God, what we are seeing here, okay, is one that hello, my network is unstable. Yes, we are saying the most right point is that one that we now would be in midway of thinking that now where could we put it? Could we have it belong to to cluster C or cluster B, hoping that the first one is cluster A, you know, and so it cannot belong to cluster A because it's so far away from cluster A, but it can only belong to cluster B or cluster C, okay? And so cluster analysis can enable us to also understand and smoothen our data in this case. Yes, Anton. Okay. All right, so when we come to data integration, you realize that quite a lot is going to be done with combining, data from one data source to another data source. And so two data source data now needs to be placed in one data store. And so data integration becomes a core activity, okay? And so the understanding of the various schemas of these two data sources would be important. And how we do understand these schemas is by looking at the metadata of these data sources. Okay, how are they coding the data? How is the data organized in their structures? Okay, and so understanding those things is one closer thing that we need to surely do when it comes to data integration. Okay, and so now those are the techniques, the tricks that surely are utilized in achieving what we are talking about. Okay, and so what the example that is before us is something similar to what we were calling the Buwembo and something. Okay, Buwembo Peter and then Buwe Peter. You know, those things might in one word the other mean the same entity. Okay, and so by going a little deeper into these various data tuples of the two, these two things, these two items, or these two entities may make you realize that this is the same person, okay? And so you want to resolve as much conflict as possible, such that at least the data that is going to be in our data warehouse surely is data that you can trust, okay? Now, apart from smoothing by say for example, by using cluster analysis, by using the regression line, it is data may have noise that that relates to data that one that is poorly distributed. Okay, and poorly distributed data would then you know, have data that is negatives. Now you'd have very smaller data, yet other data points are so huge in say, for example, in the extremes. And so now the only means of which we can, you know, correct such smoothen such kind of noises by transforming the data into a different other kind of data, which this time we know will be a standard data. Okay, and so some of the things we actually do is we may want to simply aggregate the data, okay, and simply see how we can construct any cubes. Those are smaller units of the data, okay. And then in so doing, it enables us to pick exactly a smaller set, and then can simply utilize that for your understanding, and then you go on. Okay, all we may now apply things we call like normalization. Now, normalization, standardization, all will mean the same thing. Okay. Now, normalization aims at scaling such that data falls within a small or specified range or scale. Okay. Now, such small scales or a unified scale would mean that, say, a decimal scale could mean you know anything that normalize. We are going to see how normalization surely takes place. So now we can use minimum maximum normalization, as we are going to see in the examples. We can use the z-score normalization, where you calculate your z-score of any data set or of any attribute. Okay. Or we can simply normalize by decimal scaling. So we are going to see those formulas that we use to achieve so. Okay. So in addition to the transformations, you may want to have new features calculated from existing ones. Say in their case, if you remember very well, where we have in one data source and age is captured as a number, a single number, and then the other data source age is captured as a birthday. Okay, we saw cases upon which such things take place. Okay, and so because of such challenges, challenges of people forgetting their age, challenges of people not being certain and exact. So as a data miner, a data manager, you are poised to surely use an appropriate attribute that can surely can talk about what you wanted to mean. So you want to mean age, then transform exactly the other birthday into age, and then can now transfer. You can now integrate these two data sources, because now the fields are now the same and are reading the same thing. So by data transformation of that case will enable us to achieve consistency, even as we are transferring or we integrating data from 1 or 2, 3, 4 data sources into one. Okay. Some of the formulas that we can use for minimum maximum normalization, okay, one is there, okay. the Z normalization requires you to get the mean and standard deviation given an attribute values, you know, and then the new attribute values would be calculated using that particular formula. You have attribute values, the new attribute values will be calculated using what? That particular formula, and that formula enables you to scale. So if you had 1 minus 5, blah, 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 up to 30, up to 1,000, then by downscaling it to the decimal format, we'll improve, say for example, that particular attribute values to reflect on the purpose of the entire data set. Yes, whereas I have been very, very slow, I know William will have to pardon me, but this is a session that requires much of the tasks to be done practically. And so what was supposed to be done practically, I think, and with sharing of experiences, there's no way I would have rushed this. And of course, my internet connection, okay, is one that could not allow us to achieve all this. Okay, so now lastly, but not least, even if we are going to talk about it, I would want that we further make our planning and more reading on them, okay? So with data reduction, we have seen that data is reduced to enable us use a portion of that data to get good insights as though we had utilized the entire data set or the entire archive, okay? And so data reduction aims on to making sure that we can still get the same results from simply a representation of the actual overall data, okay? And so some of the techniques or strategies that we can use to obtain a reduced representation of the data set include data cube aggregation. Yes, I would want that you can hear of data cube aggregation is simply looking at the values that we have, okay, and their type, okay, and see how you know all these values can still be further reduced, you know, into another much smaller size, okay. And so a data cube could still, if the data cube spoke about years, now we can then observe the data cube that speaks about a month, or if not a month. Some of the details that we could now see, and that is not surely a year, not a month, is about, say for example, you know, time, okay. And so aggregation enables us to do so. So from simply thinking about time, we can simply use an yearly data, okay, and will help us inform our understanding of the data, okay. We shall have reduced the huge 9.5 or 0.7 petabytes of data into such a smaller unit of the overall data for the mining or understanding purposes. Dimensionality reduction, we remove an important attribute. So even if we have 30 attributes, you can decide that these other ones might not impact. And so the data I'm going to take in for data mining tasks then will be reduced to what you're interested in, okay? And so that is we reduce the dimensions. We will reduce the dimensions of the data set in your warehouse, okay? So in the warehouse, we simply talk about essentially dimensions. Okay, and so apart from data cube aggregation and dimensionality reduction, we do feature attribute selection. Okay, so we can always reduce our data set by observing, do I need this particular attribute? Do I need that? This is not relevant. The other one too is relevant, but let's keep this. And so now you realize that the attributes will be reduced because of our selection. Okay, the selection is done backed up by certain decision or idea, and then all we could reduce in we can reduce it by simply seeing how this does fit onto our basic models. That's like how I had introduced before. Okay. And lastly, what we were seeing that you can come from time in hours, then time can become a day, and a day we can now, instead of focusing on a day, we can look at, say, for example, a distribution of drugs to be observed at a weekly basis, or if not a weekly basis, we can observe it as at a monthly basis. And later on, because we know that this too can take on another basis. So for example, yearly basis, this is also possible. So we call these hierarchy generations and discretization. Okay. In the interest of time, I would want to share this. We have a very small activity which can take an hour or an hour and a half, which I want to basically participate in with you. Although now I want to get in touch with. I have a visitor who's coming in from Eastern Uganda and wants to attend the way we offer, our online classes. I know he might get some conclusions here and there, but it's good that this is what he wants to see. Okay, so allow me, I will share this particular material now, because I have also the activity that needs to go alongside this material. Okay, and then I can prepare you for your data warehousing task. I know I would wish that class you can reserve some of my questions into the activity review. Okay. I know Joshua has been very silent today. I don't know why. Joshua has been very silent today. I don't know. Joshua, are you Muslim? You should testify. Because if it was Eid, you are very silent today, dear.
I'm paying attention.
Great. Kindly let us share this particular material, and then yes, I've stopped the sharing, and then because I want to have it reach you in your group. Otherwise, I want to see what challenges you go through. But then everything that you're going to find in the task is part of what we've just been looking at, and I hope you can enjoy it, rather than simply it being a challenge. It is something that is enjoyable if you would accept. Okay. I have acquired some flu and cough, and that's why midway of my presentation, you kept hearing me cough. It was so dusty, and now when we saw the rains, I think in one way or the other, such things spread, or cough. We brought in cough into our bodies, and then all the dust into our bodies, and now we are trying to release all this dirt from our chests. Okay, so now I think we should be good to go. I'm sharing on WhatsApp, guys. Don't wait for an email. Okay, so it is 2024 postgraduate. Okay. Oh, wow. Okay. Okay. Yes, there you go. I think you have it already. Okay. Wow. I'm sure you can kindly go into specifically this task is going to come in capturing binning and data cleaning. So surely cleaning, binning, data cleaning, and transformation. I would want to see that at least you can look into specifically those particular cases in the slides where we mentioned binning, transformation, and what? And binning, transformation, and binning, transformation, and cleaning.